My name's Caitlin Scully, and I live and work here at beautiful Bryce Canyon National Park. It's my job to tell people like you all about the amazing things we have here. One of the coolest things that we get a lot of questions about are our rocks. The geology here at Bryce Canyon is really unique, not only in southern Utah, but in all of North America. Now, our most famous rock formations that we have here are called hoodoos. Hoodoos are big, tall pillars of rock that are made out of sandstone and limestone here at Bryce Canyon. And one of the most common questions we get from visitors is, why do these hoodoos form? What creates them? Well, today we're going to be doing a really neat science experiment to figure out why. Now, most people, when you ask them, what do you think is making a hoodoo, they'll guess that it's wind and rain battering the rocks here at our high elevation plateau. But that is only a small part of the story of what creates a hoodoo. The real answers lie in our wintertime temperatures that we have here at high elevation at Bryce Canyon National Park. The most important things we need to create a hoodoo are going to be melt water, or water that is melted out from snow and ice, and freezing temperatures. Are you guys wondering what those two things take to make a hoodoo? Well, let's get started with our experiment and take a look. Now, you have to keep in mind that when you're using these sharp scissors, you gotta be careful because they're pretty stabby. So first thing you're gonna do is cut these guys not quite in half, but closer to the top. Ooh, doesn't have to be perfect. Oh, I guess there was still almond milk in that. Oops. Perfect. Let's go for the next one. You want them to be roughly the same height. That's an important thing to keep in mind. Okay, the orange eye is cut. So now we have two containers about the same size that are pretty much empty. There might be a little dry in the bottom, but that's okay. You can give them a rinse if you really want. Now for the plaster. When you're mixing up plaster, you want to make sure that it's about the consistency of a milkshake. So I'm going to add water and stir it until it's just right. Plaster is mixed. Ew. I'll just get most of that off my fingers for now. Now, our first thing we're going to do is fill up one container, it doesn't matter which one, just about all the way with plaster. Oh, it's still a little chunky. Like I said, that's okay. And you're just going to leave that one there. Our other container, you are going to fill up a little bit of the way and then put the water-filled balloon inside of it. Okay, I'm back. Hands are mostly clean. Could have done a little better. But what I just did is I mixed up a little bit more plaster and then poured it in so that these were filled almost to the top. Now, do you remember which one had the balloon in it? You can probably see. This one had the balloon in it, and the plaster is already starting to set up. You don't want the balloon to be floating on the top. Instead, you want it to be sunk down in the plaster. It's okay if a little bit of it shows at the top, but what you really want is for it to be down in the middle. Our other plaster one has nothing in it except for that plaster, and you'll see there are some bubbles at the top. An important thing to do when you're waiting for these to dry, before it even starts to harden, is you want to tap the sides to make sure that you can get some of the bubbles out of the plaster. All right, our next step is to just wait for these to dry for a little while. Depending on how wet or thick your plaster was, it could take anywhere from 20 minutes to a couple of hours. I guess I'll come back when these are dry. So let's cut these open and take a look and see if there are any differences between our two containers. Let's start with just plaster first. So use those super sharp scissors, and you just gotta kind of rip into it. So here we go. Just kind of a big, cold plaster block with a small crack in it. Looks good to me. Ready to open this one? I can already tell you by just looking at the outside, 3 of the sides look okay, but this side, can you see there's kind of a big bump on it? And there's also a big crack. So I'm kind of excited to cut into it. What we have here is a huge crack running through the entire block of plaster. What do you guys think made that big crack in it? Could it be the water in the balloon? Do you guys remember what happens when water freezes? It expands. So what we have happening here at Bryce Canyon National Park, meltwater flows into small cracks in the rock, then at night it freezes and expands and makes even larger cracks. Geologically speaking, is a type of weathering called frost wedging. When water gets in there, freezes, expands in the cracks, and then wedges big chunks of rock. All right, guys, that's our video. I hope you enjoyed it and have a little bit of a better idea about how weathering, specifically frost wedging, has a great effect here on the hoodoos at Bryce Canyon National Park. Without frost wedging, we wouldn't have those amazing spires of rock that we have here. Now, here's one more thing for you to think about. Have temperatures here on Earth been getting warmer over the last century? I think the answer is yes. In fact, people have been measuring the temperature here at Bryce Canyon National Park for almost 100 years. And back about 90 years ago, we used to have over 200 days out of our 365-day year where we had temperatures drop below freezing at night. Excellent for creating hoodoos. These days, on average, we have fewer than 150 days of freezing temperatures here at Bryce Canyon National Park. Do you think with climate change, are we going to continue to have hoodoos forming in the same way? Do you think that we're going to have as many hoodoos maybe 100 years into the future? I don't know. These are important questions to ask. Now, I hope you guys enjoyed this video. Give it a thumbs up, and I'll see you next time.